Now, so this is the eyepiece. Okay. See here. I'll explain from the beginning. This is the objective mirror. This mirror is known as an objective mirror. This mirror is a concave mirror. It's a concave mirror. And this is secondary one is convex mirror. So there are two mirrors, and one is here we have convex lens. There is eyepiece. Now, the rays from the star or from far galaxy, the light incidence on the mirror, it will on the concave mirror. So it will reflect to the focal point. Okay, it will reflect to the convex mirror, which is the convex mirror has a it has a focal point. It has a focal point behind the mirror. Now, what happens? This rays after reflection, it will come to this point. Okay, after reflection, they come to this point. Okay, so what will happen now? After reflection, they come to this point. Okay, so we have a objective mirror, we have an eye lens, and this is the secondary mirror, which is convex. Clear? So if actually in astronomical laboratory, this is in astronomical laboratory, the generally it's like a cage. There is a cage here in the eye lens. A person will sit inside the cage and he will view the image. Very big it is. Actually, these mirrors are also very huge. Actually, that's what I told you. In the telescope, which is in one is in China. When we went to Expo 2020 in China Pavilion, they have explained about this telescope, one of the biggest telescope of the world. It is equal to around 4 football grounds. That's so big. And one is on the mountain of Mexico, and there are 2 more telescopes. Right. Also. That is Hubble telescope, which is in the space. It takes the pictures and sends to NASA. And even India also has sent one telescope in the space. So it captures the pictures of the space and gives to the ground station. And that is how we interpret and we study about the space. Now, once again, there are 2 mirrors. One is concave, one is convex, and this is the very huge. See, what is the size of that one? How many meters? No, it might have given somewhere. It's very huge actually. Why? Because it has to capture more information. Larger that is whole thing. Yeah, the whole thing is a mirror. That much huge. How much size? See, check the size of the area of the thing. Now, this is parabolic mirror, or like this is concave mirror, and which is acting like an object. So, because all the rays are falling onto or incidenting onto the mirror. More 100, yeah, very big, no? So after that, it incidents on the convex mirror. Convex mirror has a focal point behind the mirror, and after that, it reflects onto this one, and the image is found on the eye lens. Okay, that is eyepiece. Is that clear? So, that is how the Cassegrain microscope works. Okay, so copy this. Then quickly we will write all the formulas of this particular lesson, and after that we will stop the class. Okay. Whenever we are writing this or drawing these diagrams in the examination, do not draw with the pen. Only draw with the pencil. Label it properly. You will get mark for this. Second book, there are more drawings. So try to get more and more marks from the drawings itself. At least they will put something. Suppose if you draw it and label it properly, at least they will give 1 mark at least, 1 or 1.5, whatever it is. Something you will get. So try to learn the drawings also properly, with the arrows now. So for formulas, N21 is refractive index of second medium with respect to first medium, and N12 is refractive index of first medium with respect to the second medium. Okay, so we'll write all the refractive index formulas. So keep that in the mind. N12 equal to what? 1 by N21. Second one is refractive index. There are 3 formulas. What are the 3 formulas? N is equal to C by V, and N is equal to sin I by sin R. Okay, and third one is N is equal to real depth upon apparent depth. real depth upon apparent. This third one is very, very important. They are asking question every time from this particular formula. Okay, now three formulas: sin n is equal to c by v, sin I by sin r, and that is also equal to real depth upon apparent depth. Okay, now after that we have the values also. Some standard values are given, and we have one more formula here. That is n1 sin theta 1. If there are two mediums, like two different mediums other than this can be used for air. If it is other than air, then n1 sin I equal to n2 sin R. Keep this now. Next form, fourth one, for critical angle. For critical angle, what is the formula? For critical angle, what is the formula? Mu is equal to 1 by sin C. Implies C is equal to sin inverse of 1 by 1. Mu is the refractive index. Okay, so that is a critical angle formula. Next is we will write I'll just draw a small tabular column with refractive index, critical angle and all. So what is the medium I am using here? And what is the refractive index? What is the refractive index? And what is the speed of light? Okay, speed in that particular medium, which is in meter per second. And last one is critical angle, C. What is the critical angle with respect to air? Okay. Critical angle, the C value with respect to air. With respect to air. So I'm starting with air medium first. Refractive index of air is 1. And the speed is 3 into 10 to the power of 3 into 10 to the power of 6. This we don't write, okay, not required. Air to air, not required. There is no critical angle. Next is glass. Glass is what? 1.5. Yeah, and then water. Yeah, tell me. What is that medium? Refractive index of second medium with respect to first medium. Okay. This is 2 into 10 to the power of 8. And this one is 1.33 and 2.25 into 10 to the power of 8. And the diamond 2.42. So therefore here 41 and 48.75. 41 degrees, 48.75 degrees, and the last one is 24.41. Okay, 24.4. These are the standard values. Just note down. It will be easy for while doing the numericals. Okay, while doing the numericals, it will be easy for you. Next one. Are you done with this? This is a tabular column. The next formula. There is magnification formula. So we have magnification formula here. Magnification formula is M is equal to H dash by S, which is equal to B by E. Fifth one. That is power of a lens. Power of a lens. The formula is P is equal to 1 by F. And F is in meters. Okay. And diopters measured in diopters or per meter. Okay. Sixth one. The angular magnification. Angular magnification is what? Capital M is equal to tan beta by tan alpha. Okay. Tan beta by tan alpha. Okay. And also, oh sorry. Okay. 6th is tan beta by tan. No, combination of lenses. I write here. Combination of lenses. That is 1 by f equal to what? 1 by f1 plus 1 by f2 plus 1 by f3. Keep something. Or we can also write P is equal to P1 plus P2 plus P3. Keeps on going. Then we can also add magnification M is equal to M1 into M2 into M3. Keeps on going. That is how we write. Next one, we have, okay, we'll copy some more formulas. Okay. For F is equal to what? Okay, very good. Are you understanding, Mr. Ahmad?
Yes, sir.
Okay, so 8th one, FEP, what is that? R is equal to F by 2. Sorry, R is equal to 2L. 9th one is mirror formula. Okay, so mirror formula is what? We have 1 by F is equal to 1 by V plus 1 by U. Okay, and M is equal to what? Minus H dash by H, which is equal to H dash by minus V by 10th one is refraction at a spherical surface. Refraction at a spherical surface. Refraction at a spherical surface. So what is the formula here? N2 by minus U plus N1 by V is equal to N2 minus N1 by R. Okay. 11th one. Okay. Next 11th one is for a lens. For lenses, the formula is 1 by F is equal to 1 by V minus 1 by V. Here we have lens maker formula. Lens maker's formula. Lens maker's formula. According to lens maker's formula, we have 1 by F is equal to what? N21 minus 1 into 1 by R1 minus 1 by R. Okay. 1 by R1 minus 1 by R. Please copy this. Then we have combination we have done. Then prism, 4 formulas from the prism we will write. Then microscopes and telescope. Okay. So after that I will leave. I could have kept in the morning. She told me to keep the. She joined now, no? Yeah, she. Because there are 4 formulas. I plus E is equal to A plus delta. I angle of incidence, angle of emergence. A for angle of prism, delta for deviation, angle of deviation. Second one, dm is equal to minimum deviation is 2I minus A. The third one is N21 is equal to N2 by N1, sine of A plus dm by 2 by sine A by 2. Fourth one is dm is equal to N21 minus 1 into A. So these 4 are very, very important. They can be used as a numerical or something like that. Okay. Write the microscope and telescope formula. Okay. Telescope and microscope formula. Now, so here, so simple microscope. Simple microscope we have when image is a near point, the formula is m equal to 1 plus d by f. And when for normal adjustment, m is equal to what? M equal to d by f. Okay, for normal adjustment it is 1 plus d. Next is compound microscope. 15. Compound microscope. The formula for compound microscope is here. There is m equal to L by f into d by f. 16:1 for refracting telescope. For refracting telescope, the formula is m is equal to beta by alpha, FO by FP. Beta by alpha, that is FO by FP. Okay. That's it. So this completes your all the formulas. Just learn all the formulas. Okay, so tomorrow we can do numericals on this.